So hello, welcome everybody. Here I am again. My name is Daniel Perez-Pinedo and I'm a researcher at MUN with the MUNPaleobiology group, as I said in the previous episode. Welcome to our second episode. We've called this episode Ancient Landscapes, the Geology of Discovery, UNESCO Global Geopark. And to discuss this topic, we are joined by Professor David Lowe from Memorial University of Newfoundland. I'm going to let you introduce yourself now shortly, but I just want to know that in today's episode we're going to be basically highlighting the geological history and the features of the geopark and how they set the stage for the future fossil episodes. But we're going to be talking about the geology of the area in terms of rock age, formation, and deposition environments, and we're going to discuss the main geological features of the geopark, like Spillars Cove, the Dungeon, Tickle Cove, etc., which, by the way, I encourage everyone to visit. It's a beautiful spot. So hello Dave, how are you doing? I'm going to just let you introduce yourself.
Hi, yeah, Danny, how you doing? I'm an assistant professor at Memorial University. I'm a classic sedimentologist, and a big part of my research program here is looking at the stratigraphy and the past events of eastern Newfoundland, which includes to some extent the Bonavista Peninsula, and I guess the Geopark as well.
Okay, yeah, perfect. Okay, thank you for that introduction. So I think I think we can start with the first question. So Dave, the first question is, can you give us an overview of the geological history of Discovery UNESCO Global Geopark and what makes this region so special in terms of rocks and formations?
Yeah, so really the geologic history goes back about 500,000,000 years ago, as you know. Um,
Yeah.
actually, you won't see this on a provincial geologic map, but more recent maps that we've made of the peninsula, along with my colleague Andrea Mills at the Geologic Survey of Newfoundland, and before her, Leon Normore, who also was a survey mapper. Um, is that there's actually two parallel geologic stories going on in
Okay.
the geopark and on the peninsula. If you look at a map of the of the Bonavista Peninsula, and you find Spillars Cove to the north and English Harbor to the south,
Right.
and more or less draw a slightly curved line between those 2 points, there's a major fault there
Yeah.
that bounds two very different parts of the basin. Two very different parts of what we call, well, the Avalon zone in Newfoundland. Um, but basically on the east side of that fault is probably where you and your colleagues are more familiar with,
Exactly. Yeah.
because that's where all the Ediacaran
Yeah.
fossils are nicely preserved. And there, I would say the sedimentary rocks really record more of an ancient deep marine, so deep submarine, hundreds, maybe 1,000 meters depth. I don't know. Nobody really knows the exact depth, but we know that this was a basin, a sedimentary basin. So sort of think a big hole in the ground. I'm speaking more generally
Yeah.
here
Yeah.
because perhaps you have a
Of
more
course. Yeah.
general audience, um, but yeah, this was a deeper basin. When you go on the west side of that fault, the stratigraphy is very different. Although the rocks are the same age, they record very different environments, paleo environments. And so, basically there they go back to about 600 million years. The oldest rocks really are part of this. I'll talk about the stratigraphy, I guess, in the next question. But basically, you go from more volcanic rocks, up through rocks that were deposited by
Right.
rivers, and then
Right.
rocks that were deposited in a shallow marine environment. So instead of hundreds of meters, we're talking probably tens of meters, and then that's again succeeded um, by more fluvial rocks or river lane rocks. And so these two basins with sort of contemporary histories, were either parts of different, let's say maybe like parts of different islands. Like if you look at modern Polynesia, it's a good example of where it's a very similar tectonic environment. And you've got areas that are more, that are islands that are subaerially exposed, and then you've got deeper basins. And so,
Right.
we think these are part of the same broad structure, or island chain, but that they later became juxtaposed, which I'll talk about in one of your later questions.
Right. Yeah, you're right. We work on the eastern side of the Spillars Cove, Ingus Harbor fault line, basically. Yeah, the fossils are on the eastern side. Yeah, I've been to the western part of the peninsula, looking at microbially induced sedimentary structures like Arumbaria, I think it's called. A colleague of mine is dealing with that. That's kind of like the only thing that I've basically done on the western side of the fault line. Okay, so the second question would be, what are the main rock formations found in the Geopark and how old are they? And what do they tell us about the ancient environments that once existed?
Yeah. So again, on the western side of the fault, we've got on the Spillars Cove fault. The oldest rocks are about 600 million years old. They're part of this connecting point group. And these are probably deeper marine sedimentary rocks. But then the record from there, you see it becomes much more shallower,
Right.
and eventually subaerially exposed.
Mm-hmm.
There are some faults and things, so the rocks were squeezed and deformed and then eroded, and then they were covered over by these younger rocks now of the Bull Arm Formation, which are probably around 590 to 585 million years old. These are mostly volcanic and like sedimentary rocks. So you can imagine, like a volcanic chain, and it's just sort of being eroded. And then those are replaced, by progressively less volcanism. So we're seeing less volcanism as we go up stratigraphy there into the Rocky Harbor group. And we see the base of that. Depends where you are, but it's kind of fluvial to shallow marine. And within that, we have the Trinity diamictite, which is this unit that records the Gaskers glaciation, which I really should have mentioned last. But this is quite significant because it helps us tie the stratigraphy together there.
Right.
Really distinctive. Well, it's like a conglomerate. So you got all these big pieces of cobbles and pebbles and things, set in a matrix of finer grained material.
Right.
And we've looked at this, and there's a lot of evidence to suggest that it's actually from a big deglaciation event.
Mm-hmm.
So that's really a key piece that's about 580 million years old. Sitting above that then are more rocks of the Rocky Harbor group. And that's finally capped by the Crown Hill group, which again are mostly riverine or sort of very shallow marine or terrestrial rocks. And they're red characteristically,
right.
Which is how they're sort of differentiated from everything. And then on the other side of the fault, which the east side of the Spillars Cove fault, which well, we start in the Druk Formation, which is probably about 575 million years. So there we don't have a record of the Gaskers glaciation, although it exists in other places on the Avalon Peninsula. So you've got the Druk and the Mistaken Point Formation, which are both probably, submarine, again, like deeper marine, submarine fan, sedimentary rocks. And those are succeeded then by the St. John's group and ultimately by the Gibbet Hill Formation. And all of these rocks we can actually see in St. John's. I mean, they're all exposed basically within this sort of greater metropolitan area of St. John's and Mount Pearl and Conception Bay, right? And of course, as you know, many of these strata, I don't know which exactly, are Ediacaran fossil bearing.
Yeah. We're going to deal with that in probably next episode or within 2 episodes. I can't remember. We have an episode on this, so we'll talk about that. And so the third question, I feel like we've kind of covered the third question already, but I'm just going to ask it, and just in case you have something to add. How were these rocks layers formed, and what kind of depositional environments do they represent, and what does that tell us about past landscapes? Is there anything you would like to add in terms of this question, or you're fine?
Yeah, sure. Well, I guess just for general listeners, I would say, because these are clastic sedimentary rocks, this is a type of rock that's formed basically from the weathering, erosion, and transport of sediment, from mountains, from hinterlands into a sedimentary basin where they settle. In terms of past landscapes, we do have on the west side of the Spillars Cove fault, in particularly in the Rocky Harbor group, our correlations Andrea, myself, and my PhD student Nicholas Gomez, our idea is basically that you head in the west, sort of more sort of mountainous, like subaerially exposed terrain. And then as you move progressively to the east towards the Spillars Cove fault, things become like the sediment becomes smaller, finer grained. So we're going farther and farther away from those hills and mountains and into what's more of a shallow marine basin. So if you can sort of like, we can sort of like define some geography there, but yeah, generally, I guess I've already talked about a lot of these aspects of sedimentary environment. So yeah.
And okay, so the fourth question would be some of the most striking geological features in the park include Spillars Cove, the Dungeon, Tickle Cove. Can you walk us through these sites and explain how they were formed?
Yes, somewhat.
Okay.
A lot of these are, there's a lot of modern geomorphology here that, I'm not really an expert in. But of course, the Dungeon, is at the tip of the Bonavista Peninsula. It's it's a coastal erosion feature. It's a sea arch and cave complex that, when the surf comes in, and sometimes you get these cool, I don't know if you've ever seen these cool floaty foam things come out of there, but
no, I don't think I have. No.
Yeah, when it's really rough, you can actually, because there's so much foam that builds up.
Oh, okay.
Some of this foam bits actually float up out of the dungeon.
Oh no, I've surely haven't seen that.
Yeah, it's pretty cool. And of course, there's tons of puffins there in the
that I've seen. Yeah.
There and then Spillars Cove. Yeah, it's incredible. The bedrock, we think is probably about the same age as the Trinity diamictite, or around about the same age. And just some precursory work on those rocks suggests that we see a lot of features that indicate really think flash floods, like really catastrophic outflow events, and probably terrestrial.
Right.
And we think a modern analog for those bedrock, again, which were deposited 580 million years ago or so, is probably like the modern outwash plains in Iceland, for example, which they call them Jökulárnar. That's our idea. It's not an idea that's been really sussed out, but the preliminary evidence suggests that. So Spillars Cove, that's really close. That's just on the,
very close,
yeah. And if we use the Spillars Cove fault, which I've already talked about as sort of a, a dividing line, the Dungeon is on the west side of that, just on the west side. And, Spillars Cove and those rocks are just on the east side. And those were, and again, beautiful coastal landscapes. I think it was featured in the live action Peter Pan movie.
It was,
yeah. And again, just you can see thousands of puffins there in July. And so those rocks, and there's beautiful sea stacks there, and you can see really cool geologic features like deformed beds and things. But basically, it's all sandstone, and much like here in St. John's, it's a very similar unit. And we think this is just like basically where rivers were spilling out into the ocean.
Right.
At that time, actually, the rocks there are probably a lot younger on either side of the Spillars Cove fault.
Right.
Sorry, on the east side, they're a bit younger than the ones on the west. And in terms of Tickle Cove, I've only been there once,
right?
Just to visit quickly. Red rocks, right? And that red comes from iron oxide. And we think there might be links to that because we see the appearance of red beds basically after the Gasquires glaciation, or above the Trinity diamictite. And there's a thought that reddening might actually be due to oxygenation of the ocean.
Right.
Which, all of these might be linked to, making the conditions right for the Ediacaran.
Exactly. Yeah, absolutely. Yeah, Tickle Cove is stunning, and it has this huge quartz veins as well everywhere. I don't know if you've seen them, but it's very, very cool. I think it's my favorite geological feature in the Geopark. Okay, so sixth question. So the geology of this region sets the stage for the incredible fossils found here. How does the ancient environment preserved in these rocks help us understand the Ediacaran life that once thrived there?
Yeah, okay. Well, as someone who's not a paleontologist or an ecologist or a biologist of any kind, I would just say that, ecosystems generally are adapted to their environments. And so, my line of research is about understanding the physical and chemical
Aspects of it.
conditions,
Right.
and but also the broader, paleogeographic and tectonic
Yeah.
setting as well. And I think that's really important, sort of in contextualizing these fossils, and sort of considering that you could potentially have, I guess, different ecosystems
For
and different
sure.
environments, and so sort of figuring out exactly what the conditions were is really important to paleoecology, I guess, and
For
even to
sure, yeah.
faunomy and things like that.
Yeah,
You
no,
know,
absolutely. Like, just to understand paleoecology, you need to understand abiotic factors as well. And for example, factors
Mhm.
like paleolatitude could be significant, where these organisms lived at the time, like in terms of tectonics and latitude and stuff. It's certainly very important to understand the paleoecology of the organisms. Absolutely, I agree. Yeah.
yeah.
Okay, and so question 7 out of 8, so we're almost there. So for visitors to the Geopark, what are some of the must-see, in your opinion, geological features that really showcase this Earth's deep story?
Well, I think many of the geosites that are established in the park are really significant, particularly those around the Ediacaran fossil sites that are accessible to the public. There is one that I think maybe isn't highlighted right now,
Oh,
but
okay.
should be and could be, which is the
Which one?
Trinity diamictite, which is
Oh,
this
right,
record of
right.
deglaciation,
No, I
right?
don't. Yeah, I don't think it
Um,
is. Not yet. I don't think.
no, so there's an opportunity there for sure because yeah, not only is this sort of distinct and very interesting, it's aesthetically interesting to look at these rocks. They're cool because for a non-geologist, you can see pieces of rocks in a rock, and it's like, well, how did those pieces get there? And it's like, well, they're transported and deposited. But from a broader sort of like you know natural history standpoint, we think it's important because yeah, we think this deglaciation, it happens at the end of this global, there are a number of glaciations leading up to this that we've hypothesized to be part of a global ice house condition called snowball Earth.
Right. Yeah.
And it's at the end of this or right after that we see evidence of oxygenation of the oceans, you know, perhaps, nutrification of the oceans that really set the scene again for the Ediacaran fauna.
Yeah.
Um, yeah, so I think that's a really significant. There certainly could be more significance, or more highlighting of that feature. And there's lots of easily accessible locations for that
Right.
as
Yeah.
well.
That's also something to take into account. Sites are easily accessible. Yeah, I agree.
Yeah, yeah. There's some that aren't, but some of the best ones aren't that accessible,
Yeah. Yeah. Yeah.
Um,
Okay. Yeah.
but
Yeah,
yeah.
and the last question, Dave, would be why is it important to preserve and study these geological features, and what can they teach us about Earth's history and even modern environmental changes, if at all?
Yeah, okay. I know that's a hard question. But I think the first part is easy to answer. I mean, this is you know, these rocks are very significant to global natural heritage, right? I mean, like, we've got a record of these, terminal Precambrian climate change events, that and also like all of the fossils themselves and the paleoecology and evolutionary insights that they provide. Um, you know, I think the fossils are really important and the rocks are really important because the rocks really tell us all about the context of the fossils and really give us constraints for the emergence of complex life on Earth. So
Right,
yeah, I mean, it's an extremely significant area in terms
absolutely.
of Earth history. Um, in terms of sort of linking this to the future, I find it a hard.
That's more
That's
tricky.
always a hard.
Yeah,
Yeah, because I mean, humanity is a blip on the radar, even
yeah,
compared to the the stratigraphic history of the Bonavista Peninsula. Completely eclipses all of modern history and even the evolution of humans. And so, um, but I think that what we can learn from these rocks is how the lithosphere, the hydrosphere, and the atmosphere are kind of coupled, and how you get dynamic feedbacks that can change ocean chemistry, change conditions, environments, and that ultimately led to the proliferation of complex life.
yeah.
Um, yeah, I think it's super important.
You,
Maybe I guess from another perspective, something I didn't talk a lot about was
okay. What is it?
Well, just the later history of these rocks too, because of course I talked a lot about the 500 million-year-old history, but there's a whole story here too about Newfoundland's geology and the geology of the Appalachians.
Mm-hmm.
Of course, Newfoundland from the west coast to the east coast is basically a cross section of the closure of an ocean during the early Paleozoic. So from about 530 to about 400 million years ago. And so famous Newfoundland geologist calls this the Harry Hibbs effect. Harry Hibbs was an accordion player. Of course, it's the continents coming apart and coming back together, right? Although it's not a very sustainable accordion because it completely changes. But so the eastern part of the province, right, of course, from the Dover Fault, which is around Gambo, all the way along to way offshore Newfoundland, is not part of ancient North America. It was accreted to ancient North America about 400 million years ago or so.
Mm-hmm.
And so that's an important part of the story too. And a lot of the landscapes and geography of the peninsula are shaped by the folding, the buckling, the breaking, and the bending of the rocks that occurred, about 400 million years ago as this microcontinent, which we call Avalonia, which, by the way, goes from New England up through the Maritimes and eastern Newfoundland and then over to Europe as well. And its history is unique.
For sure.
And so I think there's also a lot that can be told about that, although it's not as globally significant. It's also very interesting.
Oh, no, I agree. Yeah, thank you for having added that. Yeah, I'm not a geologist myself. I'm a biologist, so I'm a bit out of my depth when it comes to these things. But I still enjoy hearing geologists talk about it. It's very interesting. Thank you very much. And Dave, that was it. I hope it was not too bad. I hope you had fun, and I hope you liked it. Thank you for participating.
Yes, thank you for having me.
No problem. Thank you, Dave. Take care, and see you later. Bye-bye.
All right. Cheers, Danny.
Cheers. Bye.